Events, sample space and event. Outcome, the result of a single trial in a probability experiment. Sample space, the collection of all possible outcomes for an experiment. Event, a collection of outcomes for the experiment, that is, any subset of the sample space. An event occurs if and only if the outcome of the experiment is a member of the event. Sample space and event. An example would be a probability experiment where we roll a single die. An outcome would be rolling a 3. The sample space of a single die is 1, 2, 3, 4, 5, 6, because those are all of the possibilities. An event would be the die is even, or our result could be 2, 4, or 6. Relationships among events. Not E. The event E does not occur. In symbols, that's E prime, with an apostrophe to the right of the E. Pictorially, we would have a square representing our universe, a circle representing set E. The results for not E are shaded. Relationship among events. A and B, the event, both A and B occur. You may have seen it symbolically as A intersect B. Pictorially, you have your universe in your box. You have a circle for A, a circle for B, and where the circles overlap, that's your intersection A and B, the shaded area. Relationships among events. A or B, the event either A or B or both occur. You may have seen it symbolically as A union B. Pictorially, you have your box for the universe. You have your circles for A and B. They intersect, but all of A and all of B are shaded. So A or B is represented by the shaded area. Everything in A, everything in B, and where they intersect. Example. When one die is rolled, the following 6 outcomes are possible. You can have 1, 2, 3, 4, 5, or 6. List the outcomes constituting A, the event the die comes up odd, B, the event the die comes up 3 or more, C, the event the die comes up at most 3, D, the event the die comes up 6. We are going to begin with what outcomes constitute event A. Event A is when the die comes up odd. Our odd dice are 1, 3, and 5. Event A is 1, 3, 5. Continuing, what outcomes constitute event B? B is the event the die comes up 3 or more. So we start with 3, 4, 5, 6. Event B is 3, 4, 5, 6. Continuing, what outcomes constitute event C? Event C is at most 3. Since 3 is the most it can be, we want to look at 2 and 1 as well. Event C is 1, 2, 3. Continuing, what outcomes constitute event D? Event D, the die comes up 6. We only have one choice. Event D is 6. Continuing with our dice example, what outcomes constitute event not A? Event A, the die comes up odd, so that's 1, 3, and 5. which means not A is 2, 4, and 6. Event not A is 2, 4, 6. Continuing with our dice example, what outcomes constitute event not D? Since event D is 6, not D is 1 through 5. Event not D is 1, 2, 3, 4, 5. Continuing, what outcomes constitute event A or D? Event A is the die comes up odd, so that's 1, 3, and 5. Event D is 6. Event A or D is 1, 3, 5, 6. Continuing, what outcomes constitute event A or C? Event A are the odd dice. Event C, the die comes up at most 3. Event A or C is 1, 2, 3, 5. 3 and 5 were in both events A and C. However, you only write them one time. Continuing, what outcomes constitute event B and C? Event B, the die comes up 3 or more. Event C, the die comes up at most 3. Since it is AND, we only want the outcomes that are in both B and C. Event B and C is 3. Continuing, what outcomes constitute event A and C? Event A, the die comes up odd. Event C, the die comes up at most 3. The only outcomes that occur in both A and C are 1 and 3. Event A and C is 1, 3. Example. Determine the number of outcomes that comprise the event A and B. The following table provides a frequency distribution for the number of hours, units, a student is enrolled in for a semester. A student is selected at random. The events A and B are defined as follows. A, the event the student took between 6 and 9 hours inclusive. B, the event the student took at most 7 hours. Our data, we have hours and number of students, which is our frequency. 4 hours, 19 students. 5 hours, 26 students. 6 hours, 22 students. 7 hours, 12 students. 8 hours, 9 students. 9 hours, 7 students. 10 plus hours, 4 students. First, we want to find event A, which is between 6 and 9 hours inclusive, which means 9 and 6 are included. So event A are the hours 6, 7, 8, and 9. Event B is the student took at most 7 hours. So 7 is the largest, so for event B, we have the hours 4, 5, 6, and 7. To find event A and B, we want the frequencies where A and B overlap, which are 22 and 12. Event A and B is 22 plus 12, which is 34. Mutually exclusive events. 2 or more events are mutually exclusive events if no 2 of them have outcomes in common. Pictorially, you would have your square for your universe, your circles A and B, and they have no overlap. Another way to look at it is you have events A, B, and C. Your universe is your square, and none of the three circles overlap. Two non-mutually exclusive events. Pictorially, our first one, we have A and B. The circles intersect with common outcomes, so they are not mutually exclusive. Three non-mutually exclusive events. Pictorially, we have three events, A, B, and C, and all three circles overlap. Or we have events A, B, and C. A and B share common elements. They don't share elements with C. However, A, B, and C are no longer mutually exclusive events. To decide if something is mutually exclusive, you ask if they have anything in common. If the answer is no, then yes, they're mutually exclusive. If they're yes, then no, they are not mutually exclusive. Example: the following table provides a frequency distribution for the number of rooms in this country's housing units. The frequencies are in thousands. For one room, we have 525 units. Two rooms, 1,421 units. Three rooms, 10,922 units. Four rooms, 23,351 units. Five rooms, 27,929 units. Six rooms, 24,699 units. Seven rooms, 14,682 units. 8+ rooms, 17,278 units. And again, our units are in thousands. A equals event that the unit has at most 2 rooms. B equals event that the unit has at least 3 rooms. C equals event that the unit has between 4 and 6 rooms inclusive. D equals event that the unit has more than 6 rooms. Our question is, are the events A and B mutually exclusive? First, we need to see if events A and B have anything in common. Event A consists of 1 and 2 rooms. Event B consists of 3, 4, 5, 6, 7, 8+ rooms. Since they share nothing in common, yes, events A and B are mutually exclusive. Continuing with our example, are the events B and C mutually exclusive? For event B, we have 3, 4, 5, 6, 7, 8+ rooms. Event C, we have 4 and 6 rooms inclusive, so that's 4, 5, and 6. Since event A and event B share 4, 5, and 6, no, they are not mutually exclusive. Continuing, are the events B and D mutually exclusive? B consists of rooms 3 through 8+. D, the unit has more than 6 rooms, which is 7 and 8+. 7 and 8+ are common to both events B and D, so no, they're not mutually exclusive. Continuing, are the events A and D mutually exclusive? A is at most 2 rooms. D is more than 6 rooms. A consists of 1 and 2 rooms. D consists of 7, 8+. They have nothing in common. Are the events A and D mutually exclusive? Yes. Continuing, are the events A, B, and D mutually exclusive? Event A at most 2 rooms. Event B at least 3 rooms. Event D more than 6 rooms. A and B have nothing in common. A and D have nothing in common. However, B and D share 7 and 8+ rooms. Are the events A, B, and D mutually exclusive? No. Continuing, are the events A, C, and D mutually exclusive? A is at most 2 rooms. C, 4 and 6 inclusive. D, more than 6 rooms. A and C have nothing in common. A and D have nothing in common. C and D have nothing in common. Are the events A, C, and D mutually exclusive? Yes. Recapping. Events. Sample space, a collection of all possible outcomes. Event, a collection of outcomes for an experiment. Relationships among events. We have event E, and then we have event not E, and that makes up the entire sample space. If we have event A and B, we're looking at only the things they have in common. If we have event A or B, we're looking at the things in event A, the things in event B, and the things they have in common. Mutually exclusive events. To be mutually exclusive, the two events must have nothing in common.